Okay, let's give you guys some more practice. So get yourself a graph plotter and plot this graph here. It should then give you this. Now your job here is that you've got to draw the tangent that just touches this point here, and you're given that. Hang on, the tangent probably something like this, and you're given that this point here crosses precisely at x equals this and y equals this. Okay, so you're given this point here. Okay, and by the way, when you're given an implicit equation, always think in terms of where on the graph it makes sense. You see, at this point here, it makes sense because if you put, let's say this is x0, y0 here, it crosses at this point here. If you put this into here, and then the y into here, and then the y into here, um, this side will equal this side. So when you're given an implicit equation here, try and think in terms of where on the graph it makes sense. You see, at this point here, it will make sense because this side will equal this side. This point here will make sense because this side will equal this side. You see, this point here would not make sense. This side will not equal this side. So think in terms of where on the graph it makes sense. This point here it will make sense because at this point here, this side will equal this side. Well, anyway, find the try and somehow draw the tangent line that just touches this. Okay, and find the equation of this line here. So press pause and have a go. Okay, so to do this here, start with your equation here. So that's this equation here. Okay, and then differentiate it now. So hang on. So when you differentiate this, it will give you this. So differentiate this. That will be 4y dy by dx. Okay, equals. But from now on, well, not but I'm going to, instead of using dy by dx, I'm just going to use y prime. Okay, because y prime is really dy by dx. It's just another way. It's just another notation. It's just another way we would write dy by dx. So instead of saying dy by dx, well, I'm just going to use y prime. Okay, so here, so let's start again here. So we are currently here. Differentiate this. This will be 4y to the power of 3y prime. Okay, and then this one here, differentiate this. This will be 2y times y prime. And then here it's just x. So it's going to differentiate this. It will give you 2x. Okay, and then yeah, and then so now visualize as you've got one block equals this block here equals this block here. Add this to this somehow. Just get the y, get all the y primes on one side. So rather oops, hang on, sorry, hang on, yeah. So get all the dy's on one side. So add 2x to both sides. That will give you this here, and then uh, and then uh, and then take away this from both sides. That will then give you this. Okay, so basically try and somehow get all the dy's, all the y primes on one side. Okay, so that would then give us this bit here. Hang on. So that would then give us this, so at the moment you've got one block taking away this block here. Notice that this is in common, this is in common. Factor out the y prime. That will then give you this here, and then divide both sides by this bubble here. That will then give you this. Okay, I've just realised that you can simplify this, but never mind. Let's just leave it as it is. So now so y prime is given by this here. So now so so originally we were given this equation here. Differentiate it. It will give us y prime equals this thing here. So this thing here is what we just worked out earlier. This thing here. Okay. So y prime is given by this here. Now we want to know the gradient at this point here because we want to draw a tangent line that just touches this. So we need to know the gradient of, at this point here. So well, at this point here, because you've got the gradient is given by this bit here. So you can just put this. This is your x, remember? This is your x. This is your y. So now you can put the x into here, and then the y into here, and into here. That will then give you this. Okay. So if you put that into here, y prime equals this. So now it's just blah 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 here. Y prime equals root 3. Okay, y prime equals root 3. So going back to our original diagram, we've been given this here. We now know the gradient at this point here. Y prime equals root 3, which is this bit here. Okay, we now know the gradient at this point. The gradient at this point is root 3. It turns out to be root 3. So now we can put the root 3 into this m here. So remember, this here is our equation of a straight line. And then now that we know the gradient is root 3, we can put it into here. Okay, that will then take us to this stage here. And then well, we know the gradient, and we know that it crosses a half, and we know that the x value here is right here. So we can just put it into here. That will then take us to this stage here. And then now it's just a matter of working out c. So it's blah 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 blah. C equals minus a quarter. Okay, so now we know our equation. So earlier it was y equals mx plus c. We worked out that the gradient is root 3, and we know the intercept is minus a quarter. So our equation for the straight line is given by this. So when you plot this straight line, it will look like this. Okay, so this is your final answer here. And you can see, if you plot this line here, you can see that it just touches this point here. Okay.